So, yeah. So to explain, yes, Viresh is working on getting some notification when the performance state of this device is changing. We haven't been able to do that for scale, so I will see how and try to describe exactly what's the problem. So we have some system where this question has been raised mainly with ARM Dynamic, but in fact that can happen with any kind of system. It's just that probably just because people start to care a bit more of this kind of behavior with dynamic that it was already there in the system. So the fact that with dynamic we have more flexibility in the configuration, voltage domain, frequency domain, and so on, raise the fact that we can have some configuration where you can share voltage domain between the DSU and the little core, for example, because you want to save some voltage domain and power domain. But still keeping some frequency, some different frequency domain between this DSU and the little core. So at some point you have a shared voltage domain but different frequency domain. The point is that both sides might want to increase the voltage domain, either because the DSU wants a higher frequency or because the little core wants to run a higher frequency as well. So the goal is to select the highest voltage based on those requests. But then at the end, it means that you can have an opportunity if you're the other device in the voltage domain. They have an opportunity to also increase their performance in the frequency, just to use the optimal performance point. Otherwise, you will waste some power. And yeah, they can do. So yeah, this is clearly this example. So you have just taken this example where you have little and big CPU and the DSU. So little and big are sharing the same voltage domain. The DSU need to increase in frequency to close, for example, the big port onto higher bandwidth or higher cache speed, for example, which means that you are in a situation where you will use a high voltage but a low frequency for the little core, which means that you are wasting some power just because you are not optimal. And just because, for example, increasing voltage by 10%, increase your power consumption by almost 20%. So you will just consume 20% more power for the same compute capacity. So the goal would be, how can we notify the little cores that the voltage have increased because of another device in the same voltage domain, so you can increase this frequency to take advantage of this additional performance level. And how we can then go back to a lower frequency domain, the one that doesn't need more this performance. So in genpd, we have this set performance state that can be used to share this voltage domain and select the highest voltage domain. But then, how we can notify this device that that the voltage has changed, so that we can adjust, having in mind that we need some complex dependency in the sense that when you are increasing the voltage, you can increase the frequency after, but if you want to decrease the voltage, you must be sure that all the other devices have decreased the frequency before. The other stay in the normal range. So this is clearly the issue we are working on, and we would like to settle. Having in mind that, so we have used the dynamic in mind that this can happen with any other kind of device like video decoder and anything else.
So the thing is, run at lower frequency, even though the voltage is higher, you still save power. The dynamic power is low when you run at low.
You save some power compared to what? You will waste some power compared to running at higher frequency because you're less efficient, but your power budget is still lower than running. The instant power consumption is still lower, I agree, but the energy consumed will be higher.
Yes. You reduce the power, but
static power would be higher.
The static power would be higher, which means that if you run slower at a higher voltage, your overall energy would be worse. a static power for a longer period of time.
Yeah.
So you would actually benefit from running as fast as you can at the current voltage and hope that your idle will say.
So
You're just not
why
using that
then
voltage.
disqualify all frequencies within a voltage?
Yeah.
So basically run at the max of the frequency for any selected voltage.
And that actually means that we end up with a virtual frequency domain where you have both big and little and it will go up and down together.
So then I agree with you that one main advantage of staying at the lower frequency is when you have a power constraint situation. For example, you can't consume more than 10 watts.
If you are power capped, yeah.
Yeah.
Then yes, you have to stay with
I
it.
agree. So that's why it's worth having the ability to decrease the frequency. But when you're not power capped, it's still worse, more efficient.
Yeah.
So that's why we need some system need this kind of a flexibility, frequency and voltage.
That's what turbo does, by the way.
Yeah.
But are you planning to describe these dependencies, or is it already described somewhere?
Right now we are using more
Dependencies and constraints, right? I mean, if you want to also work for the power capitalism.
Right now we don't. What is described is that with genpd, some device, we are aware that some devices are sharing voltage domain. They can select for the performance level. This is the value to say, I want this kind of performance, which can be a voltage increase. And in genpd, you are selecting the highest request. So that's the only thing that we have right now. And the goal is that to notify the device that you have asked, for example, performance stage 1, but we are at level 2. And if you want, you can increase, you can make any change to be more optimal.
You can run faster.
You can run
basically.
faster,
Yeah,
for example.
right.
Yeah.
Because.
And race to idle in some way. So, as explained, we have this problem with dynamic, but it's true that this can happen with video further, being more and more uneven with GPU sharing their voltage domain with other device. So we think it's more generic stuff.
Yes, it is.
More than only CPU. So
Yeah, yes, it is, and we see those cases because, and mostly with the sharing of power resources between the GPU and the CPU cluster.
Yeah.
Because then you have, if the GPU runs, requires this level of voltage, then you can run your CPUs as fast as you can, as long as you are within a power budget.
Yeah.
So, yep.
And so right now we don't have any way to do that. And the point is that where we should get.
Just for the previous slide, so that problem can be, right, like where you have, I guess you also.
Oh yeah, yes.
So that
It's just that we
kind of
have
a
two
mess.
devices sharing a voltage. We need to select the max, and everybody needs to adapt.
And every time you share the voltage rate, then if
that
it's
would
between the
that would
CPU
mess
or
up like schedule where clusters are different. I mean,
So regarding this, we will have also to make sure that ground capacity is not dated at the schedule level. But that's, it's all about, if we are able to notify the little cluster, the little core that it can increase, you will increase and you will adjust this capacity as well. And for me, it's another part. Here we mainly want to have this notification, and then each driver will adapt and adjust the scheduler level to say my capacity is not this one and not the one you asked me or something like that. But that's another level. Here it's more about how to spread this and where we should do that. To be honest, we don't. So yeah, that's so where should we register? Should we do that at the genpd level, for example, or should we do that at the higher level because it's something that can be beneficial for others? That's the question. We don't have any strong opinion on that. There is advantage and backup for both sides.
So you can reuse the argumentation that we gave in the last session. Essentially, well, genpd is only used in a limited number of platforms.
Yeah.
And there are other things that don't use genpd and might, in principle, benefit from this mechanism. Although this honestly is turbo done in code, which means that we may not be that much interested in it. So I don't know.
But yeah, maybe it was to just not focus on genpd and try to extend that to a more generic way.
If there is a more general way to do it, then I would try that.
Yeah.
But I'm not sure if there is one at this
And
point.
we are not sure as well, because this can mean some main impact in some core parts.
Maybe it's having an initial approach based on genpd is fine, and then possibly generalizing it going forward if that's necessary or turns out to be necessary. Because
Also because it might be information that actually something like ES has to be aware of, right? Because if you can, for example, for thermal reason, run at a non-efficient OPP just because you cannot get the maximum one, ES has to know that you are actually in that situation.
After that, I expect, for example, for the CPU driver, CPU thread,
yeah, the same thing.
To propagate this information.
Okay.
I would prefer to do that instead of just trying to have a bypass between ES and this, because it's.
And did you, because you need basically you need OPPs for that. I mean PM OPP for that, right?
Yeah.
Because it is based on the information from there. So did you think, or did Viresh consider trying to hook it up to the PM OPP layer instead of genpd?
I think he sort of that, but it was not really. The goal was it was creating some dependency between the PMOPP and the genpd stuff that was not really useful at that point.
Okay, because well,
one thing with that is that the aggregation is happening on the level.
Yeah.
So that means that the MPD is the one.
Yes, for us, it says that genpd will be the one who knows that there is a change, and then it's how we either we directly register callback at genpd level, so we can do that, or we use a more generic stuff and make sure that not only genpd but others can also make such kind of feedback.
So as long as the genpd, the dependency of genpd is not a limitation here. I mean, if there are no possible users of it that don't use genpd right now, then that's fine. I mean, you can do it in genpd. Okay.
Yeah, then we can extend it.
Yeah, and then if there is a case where genpd is not available, then we can think about extending it. But for now,
can we try this with the regulator? Like, since this is the actual voltage that is getting modified, can't it notify the
no,
user?
we come to the regulator for that. Just because
you're actually modifying the regulators underneath, right?
No, we have been not by mouth. In the regulator framework, you specify a voltage range beginning, and you must have an union part between all the range available. Whereas right now, what's happening in some performance state is that I want to run at this OPP, and this OPP is a voltage and a frequency. And it means that you don't have a union part. And you can also have some hardware constraint saying that you can't reach.
Well, so I guess the simple answer is that you have, if you change the voltage, you don't necessarily know that this allows you to adjust the frequency somewhere, because it might just be not related to other things. So you need to know that you are sharing this, and the OPP is actually shared between, or dependent, like this OPP depends on that, which the regulator framework doesn't know about.
So one of the proposals yesterday about the campus to extend maybe this uncared space API, I don't know if it can be considered like a container of these. At least you can, you can clap the utilization code as the constraints from kernel space and just accept is.
And the point is that some people will not use it.
Yeah.
I mean that.
I mean the data structure by itself. We are talking about how to convey this feature. The data structure itself is.
The point is really about notifying more. Right now in genpd, they are already looking at the right atomic state. So detail that you have some water and just like the well. The point is more how to be notified, how to make sure, for example, and I'm not sure that you will plan at that, how to notify, for example, the task that things have not changed.
No, what I'm saying is that the notification mechanism can just insert a clamp there, and the consumer, like the energy model, we already know that, for example, the next OPP for that CPU will be clamped because of this constraint. So, it can be a consumer of the notification.
Oh, okay.
That's what I'm saying.
Now, what are you thinking as clients for the notification? Is it
For example, or some net thread, or some GPU driver, or video encoder, every device that sharing the same voltage domain. So yes, CPU track is one. For the example that we took yesterday, probably a dead track as well. And that's why we don't want to tie that to the CPU track or dead track, because that can be any other device, and we don't want to come back and say, finally we need to change it because it's not only CPU track and this interface.
And there are cases where it's even not tied to CPU at all, like GPU with a video decoder, for example.
Yeah, speak 10 minutes.
Oh,
Totally.
I think we have a one
more talk.
Yes. I don't have anything else. Just checking. Yeah.
Thank
Yeah,
you.
and then
Okay.
other than CPU factor schedulers, capacity, like you said, capacity, notification.
Yeah, but right now the CPU capacity is updated by CPU fact, for example. So if CPU fact is aware, you can update this capacity from you. The fact scale, right? The fact that we are, right. This is done by CPU fact, so we prefer notify CPU fact that will adjust. Yeah. Yes.
Right.
So, but this new kind of framework we discussed about in ES can actually be the place. I mean, it seems that different users might get information in this place. I mean, it's already right. So it might be.
This would be only for what we discussed in terms of
Yeah, I know, but why?
One of the devices.
Yeah, why not extend it at that thing? I mean, CPUs will only use the CPU energy models, but then it's all related to thermal framework and everything. So I don't know.
Yeah, I don't know. I think maybe starting with genpd.
Yeah, so
And see now how we can, if it was.
If all the current existing use cases are limited to the systems that use genpd,
Yeah,
then this is sufficient, I think. And if there is a different use case, then we can extend it. Because, whereas in case of in that case of EAS, we know that there are other existing use cases already.
Yeah.
So
yes, yeah.
so this is cool. All right.